Hello everyone, thank you for joining. We're going to cover installation and commissioning for hygienic equipment. The goal for today is to go over and review some best practices in installation and commissioning of equipment in a facility. My background is process engineering and project engineering, a little over 20 years for a small company called Campbell Soup. Unfortunately, they sold the division I was with, and now I'm with GEA on the valve and pump side. So we'll dive in here. Really, a success of a project starts at the beginning. Understanding your manufacturing strategy, understanding what your goals are for the project, your end customer, and also the characters and the institution that you're running the project in, because that can drive the success of the project. If you have say an upper management team that is not really schooled in project management and really just wants the end job done, they don't want to spend any money in pre-planning, then the success of your project is going to be at risk right out of the gate. So planning that strategy is very important, and we'll cover some of those suggestions. Comprehension of your target technologies. So there's so many equipment suppliers and so many integrators and methodologies of running. It doesn't matter if you're in brewing, beverage, pharmaceutical, and many other food operators. You have many options of selecting the technologies to get to your end goal. But understanding what their capabilities are and what their experience is will help you succeed in that as well. So if you have a very young equipment supplier, they haven't done large projects, or they are inexperienced in the project process, they can hinder the success of your project as well. So understanding that risk management and that you're going to have to put more resources against that area so you can succeed. Understand the market expectation and demands as well. So I've been in many projects where somebody had a great idea in marketing and they spent literally millions of dollars on a project, new equipment, and you go in and there's no market for that product. So you've now wasted a lot of money and a lot of resources. So understanding that, and that's all part of that planning strategy as well, and really the initial project kickoff of, is this a viable project? And then why we're all here this week is standards and regulatory bodies. So understanding what you are going to need to meet under those regulatory or standards, and maybe there's standards that you want to meet. So 3A specifically, that in this project you're going to need to meet those 3A requirements, but you may have another project that does not need to meet those 3A requirements. And then if you are running or moving your project to export countries, understanding what their regulations are as well, because they may be completely different than where you're manufacturing. Project management life cycle. These are best practices from the PMBOK. Basically, you're broken down into the 5 phases of a project. So your initiation, your planning, execution, monitoring and control, and closeout. This is where upper management generally wants to start. They just want to dive right into the execution. They don't want to spend a lot of money in the initiation or really the planning stage. And this is where most projects will be broken right out of the gate. So ensuring that you have your initiation plan and your planning stage and you have all the right people. Now you'll notice, because on the engineering side, when I say conceptual engineering, planning, there's many different engineering aspects, from your project engineers, your process engineers, mechanical engineers, so forth. So there's many more pieces to each one of these stages, but I'm going to concentrate really on these engineering sections and then into the execution. But really, these 2 pieces are where most of your time and energy should be spent, and then the execution and then really the monitoring and closeout become much easier. So the hard work is really up front. We're going to dive in to the stage 5, final design and construction, commissioning and training, and startup on the execution side. And I'll cover some of the initiation and planning as well. Project acceptance guidance. On the stage 5, you should have commissioning SMEs and tasks identified. You'll be completed at this stage. Equipment design review. So those, again, were all done in the planning stage. These should be completed before you move into the execution stage. Equipment delivered, so now that your equipment's arriving to site. But before it's arrived to site, you've completed FATs. This is very critical. I've experienced this many times. We had a labeler that was very critical to the project, and because it was in Germany, upper project managers and upper management decided that they were going to the FAT, and that none of the people who were involved, the key stakeholders, so forth, were not invited and did not attend. So when the equipment arrived and we asked for the FAT documents to say, hey, who did the checkout, so forth, none of the FAT documents were filled out. And what I mean by FAT documents, you should have quality, original engineering scope, your safety protocols, everything should be documented on a document that you're going to check out on that equipment. And before that equipment ships, all of the punch lists that you found during that FAT should be completed before it ships. And I know many of us have probably been through projects where there were issues found in FAT and the equipment still shipped because of schedule. But I can tell you from many experiences that if the equipment lands and there's many things to still do on that equipment, it's going to cost you 4 to 5 times more in the field than it would have. Delay your schedule. It's easier to delay your schedule, push people off, you're not paying them. Yes, it's unfortunate, and you might have to shift some of the resources around, but if that equipment arrives and still needs a lot of work, and you're shipping in, or the vendor is sending their people in to still weld or grind or modify the equipment on site, it's going to cost you a lot more money. The quality audits of the set equipment. So you should have quality documents that basically your quality team and your operators are involved with to go over that equipment to ensure all of the standards have been met, all your safety audits and the safety requirements that your plant requires. Many plants have different safety managers, key in on different things. So just making sure that before you even start up that equipment, everything is in place. And then punch lists. At this stage, your punch list should be substantially completed. There shouldn't be things, especially on a safety standpoint or on an equipment standpoint, where the vendor has to be standing there making the equipment run because your operators cannot run it at that stage. That means you're still back into the equipment acceptance. So if your vendor's operating your equipment at your startup, you have issues. A lot of things that I'm skipping over because we only have 45 minutes, but I do suggest, you don't have to go get your PMP to run a project, but there is great guidance in the PMBOK to guide you through the planning stages and the execution stages, and really all stages of the project to help you be successful. And then your project acceptance guidance. You're at stage 6 now, your commissioning kickoff meeting, and so this is important. So you have all your stakeholders, all quality, all operators, everybody who's involved in the commissioning stage. Don't leave people out. There's a lot of times where the core team meets and all the other people are left out, but they're still expected to operate and commission the equipment. And again, safety review. So the whole commissioning team should be reviewing the safety, and if there's any other items that come up during those meetings, address them before you go out to the plant floor. And then again, the quality reviews, same thing. Review those documents. Make sure that you have all your quality issues resolved before, or concerns resolved, or they may be low-level items both on safety and quality, and it's a longer-term fix as long as there's not a safety or a product quality, or you're going to induce product safety issues as well. And then your punch list is now operationally complete. Again, you might still have some building punch list items or engine room punch list items, but you should be at an operationally complete stage at this point. GMPs, SOPs, SSOPs are established. So these are critical, so when the employees are walking out to the plant floor, they know where they're going to wash their hands, they know what PPE is required, they know the standard operating procedures have been written based off the OEM recommendations. Obviously, they're still going to be modified as you move forward. And then your SSOPs for your sanitation team to ensure they understand how they're going to clean the equipment. You start into the systems functional checkout. Now this is the operator functional checkout, not IO checkout or engineering still on site doing IO checkout or equipment checkout. You should be through that process. I've been in situations where plant managers have wanted the key stakeholders or operators to be involved in IO checkout and really the deep dive commissioning of that equipment. I can say do that selectively. If you have some key operators, involve them, don't bring in 20 people. I had the experience of a plant manager wanting everybody involved in every stage, and we were doing IO check on a very automated homogenizer system, and they basically stood on the plant floor watching us for about 15 hours because none of them know controls, none of them know electrical, and the plant manager walked in and asked, "What's everybody doing?" I said, "Well, none of them are electricians, none of them are controls engineers. I don't know what you want," and that was the last time we ever did that. So it is nice to have people involved, but do it selectively. And then operator training. This is critical to ensure that as you move in, having that operation training plan. I've also experienced where, for whatever reason, operator training was decided to be moved to HR, and HR was responsible for operator training of the equipment. And so I was very concerned, and I kept raising the concern, when are people coming in to do the training? And they're like, "Oh, don't worry about it, HR has it." Okay. The day we came in to start doing the commissioning kickoff and start operating the equipment for day one, their training was, here's where you clock in, this is where the lunchroom is, and this is where the restrooms are. So let's just say that that startup did not go very well. It delayed us greatly in that operation. You're through those kind of learning curves and also some of the struggles. You will have struggles, there'll be hurdles, there'll be new punch lists that are created, but that's all part of the project process. Stage 7, again, you're doing a startup meeting, you're going to run your first test products. And so this is where all of the safety reviews, quality reviews, everybody's in agreement, punch lists are complete, engineering and vendor support is on site. So, and when I say engineering and vendor support, if you have major equipment, your vendor should be on site. Pay for it because it will help you go through the commissioning process and the training process and start up much smoother. The other key piece is your engineering. I can't count how many times a company will pay for the engineer of record, has done all the design for the facility, and at commissioning, because they don't want to pay for having those engineers on site, they let them go, and the engineers actually never see the final product of what they've done, and they're not there to help. That will hinder you in multiple ways. One, most engineering firms will find their own errors and will take pride in it and fix it on their own. And generally, they're not going to come back with a change order because they understood what their mistake was. So there's pride in their work as well. But it also helps you get through the commissioning process because they understand from day one what the goals were. They did all the drawings, they've done all the reviews, and they've helped throughout the whole process. So releasing them at this stage is detrimental, in my opinion, to your project. Put it in your budget. If your budget's so tight that you cannot do engineering support during commissioning, you can't do as-builds, a tough thing to say is maybe the project shouldn't have been done. Because if your capital is so tight that you can't execute the project correctly, the chances of you failing increases dramatically. Or you end up spending way more money, and I've seen that too, where companies have had to go back and ask for funding up to 3 times, and they're over their budget because they did some incorrect things along the way in the project. And then start performing your quality runs. These are not for sale. These are basically making sure the equipment is running and operational and is performing to the quality requirements of your facility. And then perform your equipment acceptance testing during those runs. So this is where we're baking cinnamon rolls or muffins here, but it could be any type of product, but making sure that they're meeting those quality requirements, and if they're not, understanding what they are and who is responsible to fix them. So now we're going to get into a little more. So the main section of this was project management, but then also valve startup and commissioning as well. Technical objectives of your validation. Ensure equipment and systems meet original requirements that were set and provide objective evidence that all of those objectives have been met. SMEs don't abandon, again, your engineers of record, so this includes all your process engineers and your mechanical engineers. And then your validation requirements. So we talked about the quality documents, but diving a little deeper, so you should be identifying the locations where you're going to be doing your quality testing, so swabbing or whatever tests have been deemed adequate for that validation of that equipment. Your sanitation programs established and your CIP system parameters established. I talked about SSOPs and SOPs, but this is a critical piece in understanding what actual method are we using in your sanitation program, open plant cleaning, COP, CIP, SIP, and making sure that during that commissioning stage, all of those systems are running before you get into the validation stage. Because your validation is basically stating that what we have decided to do is producing clean, adequate equipment to produce healthy and unadulterated product. Method of validation testing. Is it visual? It will be visual, but also microbial testing. Are you doing total plate count, ATP, Listeria, Salmonella? Are you doing allergen testing? So, and there's others that are in here too that you can add to this list depending on the product, but it covers a broad range here, but there might be, especially in brewing, there's other things that they're looking for, but dairy's going to be looking for other things as well. But at the end of the day, understanding and having that documented and everybody agree to what those tests will be, what the pass-fail method will be, and also if there are issues, who is going to resolve them. Obviously, you don't know that when you go in where that problem's coming from, but identify it. Is it coming from the CIP system? Is it part of inadequate open plant cleaning? But identifying them and resolving them before you go into that final validation. I highly suggest having a validation program. I say this because this is missed in the 3A document. So I have customers who will say, my equipment must be 3A or I won't put it in. But there's a lot of pieces of equipment that a company has not decided to spend the money to have it go through that 3A approval process, but it still may be the right equipment for your operation. In those cases, FDA, USDA, all of your regulatories all have an out in those situations. And that is a written validation program. So if you can prove the equipment you've installed has gone through your validation and you have written documentation of that, you meet the requirements because you have proof that it's cleanable and it has no microbial issues in the process. However, starting off with the 3A standards is always a great place to start because it's already been reviewed and there's other people in the industry that are using that equipment. Hygienic valve sanitation considerations. All parts in contact with product must be cleaned at a regular interval. Always observe the operational manual and tend to use. This is one that we struggle with a lot. We get a lot of phone calls on equipment and no one's read the manual. So this goes way back to the planning stage and the SMEs and the stakeholders. All the manuals, all the spare parts, all of that information should have been provided, and the expectation of those individuals is they've read those operational manuals before you get to the validation and the operational stage, because it can answer a lot of questions. Most manufacturers have pretty good OEM manuals. I've seen others that leave a lot out, but use the manuals. Always observe the chemical safety data sheets. Use cleaning agents what don't cause damage to seals and parts. So we see this often. We don't receive all of the information. Somebody selects EPDM or FKM or other seal material, and I know there was a seal presentation yesterday, but this is critical for your performance long term. If you're repairing valves constantly on your seals, there's a very good chance either the wrong valve was selected or the wrong seal material was selected, which is normally the case. And then CIP solutions should flow through all product contact areas of a valve. So this goes back to your engineering stage as well. I know most of you have probably heard this many times, but there is a bias, if you will, to always look at your process design on a product standpoint, and cleaning and CIP becomes secondary. I can tell you I've seen both sides. I've seen where the product was primary, CIP was secondary. Somebody, a plant manager, somebody saw a 3-tank CIP skid at a trade show and they bought it from the show and they dropped it in the plant and expected it to work. Haven't seen that one work. So understand flow through those contact portions are critical in including that CIP and that cleanability at the process design stage. And that should be paramount, because we don't start with product, we start with cleaning, and then we run product. But most people look at it as opposite. I'm going to run my product and then I'm going to clean. But so did you start with a soiled pipeline before you ran your product? No, you had already cleaned it and sanitized prior. So it's very critical, and it will generally save you more money. Your system will be more efficient, not only on a energy and resource standpoint, but also a product throughput standpoint. Your cleaning method should be established by a consulting OEM and chemical supplier, so include your equipment suppliers, but also include your chemical supplier because they generally have a lot of knowledge in the CIP space. If your chemical supplier doesn't have a lot of CIP knowledge, then look for outside resources. A lot of times your engineering firms will have people who are very trained in commissioning CIP systems, so utilize those resources as well. Based on product type, relevant process and quality team expectations, a lot of times you can have one person in a quality team that has different expectations than the rest of the team, and when that happens, it slows your project down. So allowing people to express their concerns before you get into the stage and addressing those are critical if they're addressing those concerns. Or just to be blunt, some people just want to be busybodies and be the center of attention. You go through them, but if you have all your documentation and your validation, generally you can squash those concerns because your whole point is to validate and prove that it's cleanable. But if there are regulatory issues that are found, address them and move forward in the project. And then cleaning effect and reliability of clean depends on multiple things. So design, that's the key piece, is you can have the best chemicals, you can have the best people, but if you have a poor design, those individuals and the time and energy that will be required to clean that poor design is going to be detrimental to your operation. Ensuring that you have a good design up front is critical. And there's a lot of resources. We deal with a lot of times where, I'll pick on Jason a little bit, they'll send us a valve list. They've already selected every component of the valve, and we don't know what the product is, we don't know what the operation is, or the actual issues or potential issues. We just get a valve list and we order it and it arrives, and then there's issues in the field. Either, as I stated earlier, elastomers, incorrect actuators that were chosen, the wrong valve for the type of flow that they're dealing with. So yes, we do have salespeople. There are people that don't like to deal with salespeople. We also have technical people, and we're there to help not just the customer, but also the engineering firm select the right valves and equipment for the process. And in those cases, a lot of times we can actually reduce the number of valves required and or ensure that there's the right flow or velocities going through the valves. I had a situation where a company just put in 5 new silos. They commissioned, and every single valve had the wrong actuator closing pressure on it, and they had to spend $100,000 to go through and change those actuators because the engineering was done internally and they didn't do any pressure loss calculations, which was very odd, but that was the situation. They also were unloading 3 trucks at a time into a 3-inch valve, almost 600 gallons per minute through the valve, and they were wondering why our valve was vibrating. We did computational flow analysis, and unfortunately the valve was actually a tangential. I won't go into too much detail, but they were running 33 feet per second. We really don't, like, red for us is about 13.5 feet per second. They were already at 33, and because of the tangential, the flow was coming through the bottom of the valve, coming back around, collapsing into the new incoming, and in the corner of the valve, we were at 133 feet per second entering the tank. At that point, we were like, yeah, we can't warranty the valve. You should have put in at minimum 4-inch, but you should really be at 6-inch. They didn't like that answer. Basically put in a con entry on the housing. They're still running at 33 feet per second today, but because we don't have the collapsing back and the internal flow, we reduce their problem. However, we still will not warranty the valve at 33 feet per second. So those are pieces in design. Those could have all been solved if somebody would have done the pressure drop calculations, somebody would have known, or if they did know that they were going to unload the 3 trucks simultaneously, helping the customer avoid those issues, because it costs you so much after the fact. Generally, and I know there's industry standards, but generally from a new project and you have to redo it, it's up to 6 times more costly to redo a piece of equipment after the fact. So spend the time up front in the design phase. But time, temperature, mechanical, chemical, the people piece is critical too, and that really comes back to the training and the planning and selecting the right people. So I should have mentioned it earlier in the slide, but I'll mention it now, is your team selection of your project. In larger corporations, everybody wants the equity and inclusion of everyone. However, if you're the coach of a Super Bowl winning team, are you, as the coach, allowing other people to dictate who's going to be on your team, or are you selecting the team members to make it and win the Super Bowl? It's the coach that's doing that. So ensure that you have the right people, and that's hard, and if you don't have the right internal people, find the right external people to help you meet your requirements for your project. Valve setup and commissioning. Mix-proof valves are used for the mix-proof shutoff of high-grade, non-abrasive products at intersection points and pipe systems. We say non-abrasive, we do have methods to assist in abrasive products as well, but in general, most of the products in the industry are at a non-abrasive standpoint with a few exceptions. But prerequisite for reliable and safe operation of the valve is professional installation and assembly. So we had the seal presentation, we had the welding presentation, we had the secondary food contact presentations. All that is included in this section. I can tell you when we have manifolds, so we'll build manifolds, and many other people in the US will build manifolds, but making sure that you're selecting people who are experienced with that type of piece of equipment. Because there's many, many times that we've had to come in after the fact and manifolds are sagging, they're not pitched properly, they're not draining properly. The valve can only do what it can do within its scope. The things that are done around it, it cannot control. That's where the design comes in and the final build. Adhering to operating and inspection and maintenance instructions. So again, reading those manuals. Only qualified personnel may work or remove the valve from service. This is important in communication. So especially when after you're in operation, The mix-proof valves are designed to protect your product. However, I've seen many HMI systems where any operator can put a valve in manual, they can do seat lifting, so forth, and I have been part of multi-million-dollar product losses because of a valve being shifted when it shouldn't have. And those are all preventable. The valve can only do so much mechanically, and this is where your controls come in and understanding the safeties that should be put in around your control systems. And either we or your integrator can assist in those as well. Also, understanding and communicating with your operator. So if there is a valve issue and it needs to be serviced, understanding when the maintenance people can pull that valve from service, when they can shift it. Again, I've seen where somebody said, hey, we have a problem with the valve. Maintenance person hasn't communicated with operations. They don't know. They're still running product. They should know, but they didn't. And they shifted the valve manually at valve location. And then again, they've contaminated a run of product that now cannot be sold. A prerequisite for reliable and safe operation of the valve, personnel must wear suitable PPE. So understanding your product and the potential chemical safety of what could be in the line, but also line break procedures. Highly suggest a line break procedure or a work order that's out of compliance work order. I know there's many different terms for it, but basically if it's a non-standard practice, having something that you're documenting, the team, either safety is involved, but also your operators and your maintenance team. So everybody's in agreement what the safe method is. Locking out pumps, bleeding off lines to make sure there's no safety issue. Some of the pressures we're seeing, especially around membrane units, are up to 900 PSI. Pulling a valve at 900 PSI will be detrimental to the people around and detrimental to your equipment. And then high caustic levels or acid levels that are in the CIP system can be a problem as well. Clearly define those procedures, competent and responsible people working on the valve. Everybody must know what to do in case of emergency. So a lot of these valves, especially in manifolds, this is where the design stage come in, and I've seen where people have had to put a piece of plywood on top of the control tops, crawl out 30 feet above the ground. They're harnessed and they're trying to pull a 4-inch valve. That's a poor design issue. So making sure in that design that how are we going to service this? And that's probably what we see the most is the process, and even CIP was all done correctly, but no one cared what the maintenance people were going to have to do to get to those locations. And there's many, many things that can be done in a design or a process design to allow safe access to an area. Understand and follow the OEM guidance for control and feedback systems, so understanding what those systems are. In our case, there's methods for putting a valve into maintenance mode. There's also, if a valve is faulting and it's causing, especially if you're in a very large manifold, a lot of your process safety protocols in the controls will fault out the whole manifold because that one valve is providing incorrect feedback. There's method in most manufacturers to put that control top into a bypass mode where it will not accept a signal and it will not move, but it will basically send an OK signal so that your operation can continue to operate until you have time to get to that valve. And in our case, the valve will basically blink a different color to tell you, hey, I still have an issue, I'm in a safe mode, but that allows your operation to continue its run as long as it's been determined that it is safe to continue to run in that state. Different type of mix-proof valves, and this is pretty standard throughout the industry on the types, but standard mix-proof, non-balanced in this case, a lower balanced valve, but what we refer to as an axial seal, so metal-to-metal stop with controlled compression, and then what we refer to as an R, but is a lower balance, axial upper and a radial lower, so this prevents spitting when the valve is in main stroke. Our PMO valves, upper balanced and lower balanced valve with a different internal cavity for the valve. You'll also notice there's some connections in these locations. This is for spray cleaning or external spraying of the cavity based on your product requirements. This is a spray cleaning operation, so if you have very sticky, high particulate product or many other reasons, you can do an external spray that cleans out the inside of this cavity under higher pressure. And then, but you also have your seat lifting, so upper seat lift, lower seat lift, that you're cleaning the seal areas and also cleaning the cavity. So understanding how the valve operates and where your product is in contact with the valve is critical on the validation stage of the product. Some overviews, these are only guidance. This is all up to your quality team, your engineering team, so should have influence, and your controls team on when and how often those seats should be lifted during CIP. The one critical piece, and I see this very often and why I mention it, is the program will be set to start seat lifting as soon as the program starts. These should really always be tied to verification of flow at the end of your line, not at the start of your line. So you want to make sure your line is completely filled before you start doing any seat lifting, because if you start right away, you haven't verified flow, all you're doing is dry lifting and there's actually no cleaning solution or pre-rinse that's happening within that area. Then last piece is the swabbing locations of the valve. So selecting the swab location within the valve, should be part of your quality documentation. So when that valve is pulled, you're swabbing on the stem, you're swabbing inside the cavity, you're swabbing the housings. Those are your points of product contact, and you should be getting negative results if your CIP and chemicals are doing their job, or if you're doing heat sterilization. All these surfaces should be negative during that validation. And most validations require 3 passes for that validation, and if you fail any one of those 3, the clock starts over and you have to do revalidation again. And when you say validation, it's not the very first time you run new equipment. It should also be if there's modifications in the process line, a pump was changed to a different type or different flow rates, the validation for that section should be redone as well. Or if you've changed the product type considerably, you've gone from, let's just say, came from a lot of soup, so we're just doing a water-based product, and now we're doing a very heavy cream-based product. Those products are going to require a different cleaning time or potentially even chemical changes or mechanical changes to ensure that validation passes. Some other pieces of equipment outside of valves, so understand other valves and process devices in your system. This is devices around a tank. You have single seat valves, you have reverse acting valve, and my area, so there's also a very big tendency to always use a branch T for instrument devices. So in a lot of cases, it works for fluid, but if you have high particulate or very sticky products, or you have a CIP system that's compromised, so you're running at limited flow rates or minimum flow rates, you can have issues in these branches. So to solve those, basically using the same type of housing you would in a valve, and all of your instrument suppliers, we don't supply the connections, it's the instrument, so all of your major instrument suppliers, and we're not the only ones that produce this type of instrument housing, there's many others as well, but it's a cleaner and easier to clean in your process. And I say this on the validation standpoint because I've had many situations where we've failed validation in these areas, where we've removed and put in a cleaner instrument device and then passed those validations. And then the last couple slides here, I'll mention this valve. So on a design, a divert valve and a converge valve, or you'll hear them called non-slamming diverts. These are the 2 valves that are most misused in a facility and will cause water hammer in your facility. So anytime there's water hammer in the facility, I ask where the divert valves almost first thing, because they almost always cause, and for whatever reason, the engineers get these 2 mixed up constantly. So always running against flow. So for those that don't know, this is a divert valve. So flow is coming from the center, and I'm either diverting to the upper or the lower path. This is a converge valve, so my flow is coming from bottom to center or upper to center. So I'm always closing against flow. What's inducing water hammer is closing with flow. So if I have flow coming from the upper to the middle and I close with that, it accelerates the stem, and that's what causes your water hammer. And water hammer is going to cause not only valve failure, an increased maintenance protocol, but it can be detrimental to downstream equipment. So we won't cover it here, but if you get really bored, go to YouTube, look up water hammer videos, and there's some pretty impressive engineering. I mean, you're talking 50 to 80 Gs of force under water hammer conditions. And these valves are designed for about 16 bar for reliable operation. If you go above that, again, those 33 feet per second, and you do water hammer where your fluid's already running at that speed, we've seen stems broken, housings bursted. We actually just saw a side of a pipe that literally they blew fluid through the side of the pipe due to water hammer issues. So we can help solve that, and your engineers can help solve those problems too. And then this is a mix-proof divert valve, not very common, but if you have a situation, generally I'd question the engineer what they're trying to accomplish if they're using a 6-ported valve, but in some cases it is required, but it is a mix-proof, but a rare, and then butterfly valves as well. So the last piece, validation records and recommendations. Certified startup procedures, your CIP records are recorded time, pressure, temperature, conductivity, titrations, flow, change control, and revalidation procedures. The change control is critical for your PLC and your pinning charts. So if you have people that are working at night and can get to these items and they just change because they ran into a problem, they may not understand all of the process, and you have no controls over those changes, you can cause issues for your product and your process. So ensuring you have good change control management and revalidation procedures under those controls. Initial maintenance and intervals established, so those are the critical spare parts on hand. I know this is always a contentious one because a lot of plant managers want the spares purchased under the capital project. However, we're not the government. The government says you can't do that under capital. So there is some unique ways that you can do that, so change some of the wording. But at the end of the day, make sure the spare parts are on hand, and then project acceptance sign off. And at this stage, there's lots of hours, lots of lost sleep, but a lot of celebration if everything has been followed and the project is successful. Thank you.